Chapter 3 Factors and Multiples. Dad, at the last signal, the traffic light turns in 45 seconds. But here it's showing 60 seconds for turning green. Is it possible that all traffic lights turn green at the same time? The LCM of 45 seconds and 60 seconds will be the time at which both traffic signals will green. Factors. A factor is a number which divides another number without leaving a remainder. Example, 15 divided by 5 is equal to 3. 15 divided by 3 is equal to 5. Both 3 and 5 are factors of 15. Properties of factors. 1 is a factor of all numbers. 1 is the smallest factor of a number. Every non-zero number is a factor for itself. The largest factor of a number is the number itself. 1 is the only number that has only one factor, which is number 1 itself. Finding factors. Example 1. Write all the factors of 16. Solution. 1 into 16 is equal to 16. 4 into 4 is equal to 16. 8 into 2 is equal to 16. 16 into 1 is equal to 16. So, factors of 16 are 1, 2, 4, 8 and 16. Clearly, every number has finite number of factors. Common factors. Let us write factors of 18 and 30. The factors of 18 are 1, 2, 3, 6, 9 and 18. The factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Clearly, 1, 2, 3 and 6 are common factors of 18 and 30. Thus, the common factors of 2 or more numbers are the common numbers that can divide those numbers exactly without leaving a remainder. Multiples. Observe the following. 4 into 1 is equal to 4. 4 into 2 is equal to 8. 4 into 3 is equal to 12. 4 into 4 is equal to 16. Here, 4 has been multiplied by 1, 2, 3 and 4 consequently to get the products as 4, 8, 12 and 16 respectively. So, the multiples of 4 are 4, 8, 12, 16 and so on. The multiples of a number are obtained by multiplying the number consequently by each of the natural numbers. Finding multiples. Example 2. Find first 5 multiples of 6. Solution. 6 into 1 is equal to 6. 6 into 2 is equal to 12. 6 into 3 is equal to 18. 6 into 4 is equal to 24. 6 into 5 is equal to 30. So, the first 5 multiples of 6 are 6, 12, 18, 24 and 30. Example 3. Find first 6 multiples of 13. Solution. 13 into 1 is equal to 13. 13 into 2 is equal to 26. 13 into 3 is equal to 39. 13 into 4 is equal to 52. 13 into 5 is equal to 65. 13 into 6 is equal to 78. So, the first 6 multiples of 13 are 13, 26, 39, 52, 65, and 78. Properties of multiples. 1. Every number is a multiple of 1. 2. Every multiple of a number is either greater than or equal to that number. 3. Every number is the smallest multiple of itself. Common multiples. Let us write the multiples, a few multiples of 5 and 15. The multiples of 5 are 5, 10, 15, 20, 25, 35, 40, 45, and so on. The multiples of 15 are 15, 30, 45, 60, 75, and so on. The common multiples of 5 and 15 are 15, 30, 45, and so on. Thus, the common multiples of two or more numbers are the common numbers that can be divided by those numbers without leaving a remainder. Divisibility rules. We can find out a number is divisible by another number by some basic rules of divisibility without actually dividing the number. Divisible by divisibility test. Example: 2. If the last digit is 0, 2, 4, 6 or 8, 286 is divisible by 2 since the last digit is 6. 3. If the sum of the digits is divisible by 3, 285 is divisible by 3 since the sum of the digits is 15. Round bracket 2 plus 8 plus 5 is equal to 15 and 15 is divisible by 3. 4. If the number formed by the last two digits is divisible by 4, 420 is divisible by 4 since 20 is divisible by 4. 5. If the last digit is either 0 or 5, 285 is divisible by 5 since the last digit is 5. 6. If the number is divisible by 2 and 3 both, 456 is divisible by 6 since it is divisible by 2. 8. If the number formed by the last three digits is divisible by 8, 9128 is divisible by 8 since 128 is divisible by 8. 9. If the sum of the digits is divisible by 9, 639 is divisible by 9 since sum of the digits is 18. Round bracket 6 plus 3 plus 9 is equal to 18. Round bracket closed is divisible by 9. 10. If the last digits is 0, 2550 is divisible by 10 since the last digits is 0. Divisibility by 11. A number is divisible by 11 if the difference between the sum of the digits in the odd places and even places is either 0 or a multiple of 11. Example 4. Check whether 9878 is divisible by 11 or not. Solution: 8 even places, 9 odd places. Sum of digits at odd places is equal to 9 plus 7 is equal to 16. Sum of the digits at even places is equal to 8 plus 8 is equal to 16. Difference is equal to 16 minus 16 is equal to 0. Thus, 9878 is divisible by 11. Prime and composite numbers. Prime numbers. We have already learned that every number except 1 has at least two factors. A number greater than 1, which has only two factors, 1 and the number itself is called a prime number. Prime numbers up to 100. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 61, 67, 71, 73, 79, 83, 89, and 97. 2 is the smallest and the only even prime number. Composite numbers. A number greater than 1 which has more than 2 factors is called a composite number. Example of composite numbers: 4, 6, 8, 9, 10, 12, 14, 15, 16, and so on. The number 1 is neither prime nor composite. Why? 1 does not have 2 factors, so it is not a prime number. 1 has only one positive divisor. It cannot be written as a product of 2 factors, neither of which is itself. So, it's also not composite number. 4 is the smallest composite number. Twin primes. 2 prime numbers with a difference of 2 are called twin primes. There is a composite number between the twin primes. For example, 3 and 5, 5 and 7, 11 and 13, 29 and 31. Co-prime numbers. 2 numbers with only 1 as the common factor are called co-prime numbers. Co-prime numbers are not necessarily prime numbers. For example, 4 and 5, 5 and 11, 18 and 23. Prime factorization. Factors of a number which are prime are called its prime factors. Factors of 54 are 1, 2, 3, 6, 9, 18. Prime factors of 54 are 2, 3. A number can be written as a product of its prime factors. For example, 54 is equal to 2 into 3 into 3 into 3. A factorization in which every factor is prime is called prime factorization of the number. All composite numbers can be expressed as a product of their prime factors. Finding prime factors of a number. 1. Division method. Prime factors of a number can be found by repeated division by prime numbers. Example 1. Find the prime factors of 90. Solution. Consider the following steps. Step 1. Divide by first prime number 2. Go on dividing until the quotient is not divisible by 2. Step 2. Then divide by the next prime number 3 and so on. Step 3. Continue dividing until the quotient is a prime number. 90, 2. 45, 3. 15, 3. 5. Prime number 90 is equal to 2 into 3 into 3 into 5. Answer: 90 is equal to 2 into 3 into 3 into 5. 2. Factor tree method. Prime factors of a number can also be found by factorizing in a pictorial form called a factor tree. 8, 2 into 4, 2 into 2. 8 is equal to 2 into 2 into 2. Composite numbers 8. Prime factors 2, 2, 2. 18, 2 into 9. 3 into 3. 18 is equal to 2 into 3 into 3. 18. 125. 5 into 25. 5 into 5. 125 is equal to 5 into 5 into 5. Composite numbers 8, 18, 125. Prime factors 2, 2, 2, 2, 2, 3, 3, 5, 5, 5. Example 2. Find the prime factors of 80. Solution. Step 1. Divide 80 beginning with the smallest prime factor of 80, that is 2. Step 2. Next, find the smallest prime factor of 80 and divide 80 by 2. Step 3. Continue dividing by the smallest prime factor in every step. Step 4. Stop when you get only prime numbers. Answer. 80 is equal to 2 into 2 into 2 into 2 into 5. Highest common factor. Highest common factor, HCF, or greatest common divisor, GCD, is the greatest number which divides two or more numbers without leaving a remainder. Understanding HCF. Example 1. Find the HCF of 10, 12 and 16. Solution. Factor of 10. 1 into 10 is equal to 10. 2 into 5 is equal to 10. Factor of 12. 1 into 12 is equal to 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. Factor of 16. 1 into 16 is equal to 16. 2 into 8 is equal to 16. 4 into 4 is equal to 16. Factor of 10 is equal to 1, 2, 5 and 10. Factor of 12 is equal to 1, 2, 3, 4, 6 and 12. Factor of 16 is equal to 1, 2, 4, 8 and 16. Common factors of 10, 12 and 16 is equal to 1 and 2. Answer. Highest common factor, HCF, is equal to 2. Finding HCF. We can find the HCF by two methods. 1. Prime factorization method. B. Division method. Finding HCF by prime factorization method. Example 2. Find the HCF of 52, 28 and 68. Solution. 52 divided by 2. 26 divided by 2. 13. 28, 2. 14, 2. 7. 68, 2. 34, 2. 17. 52 is equal to 2 into 2 into 13. 28 is equal to 2 into 2 into 7. 68 is equal to 2 into 2 into 17. HCF of 52, 28 and 68 is equal to product of common prime factors is equal to 2 into 2 is equal to 4. Finding HCF by long division method. This method is, however, too long for finding the HCF of large numbers. For this, we use the successive division method. Example 3. Find the HCF of 216 and 1176. Solution. Step 1. Divide the bigger number by a smaller number. The remainder 96 is the first remainder. Step 2. Divide the first divisor 216 by the first remainder 96 to get the second remainder 24. Step 3. Divide the first remainder 96 by the second remainder 24. Continue this until the remainder is 0. The last divisor is the HCF of the two given numbers. 1176 divided by 216. 5. 1080, 216. 96, 2. 192, 96, 24. 4. 96, 0. The HCF of more than two numbers can also be found using the successive division method. Example 4. Find the HCF of 144, 180 and 192. Solution. First find the HCF of 144 and 180. 180, 144. 1, 144, 36. 144. 4, 144, 0. The HCF of 144 and 180 is 36. Then find the HCF of 36 and 192. 192, 36, 180, 5, 12, 36, 36, 3, 0. The HCF of 36 and 192 is 12. Answer. The HCF of 144, 180 and 192 is 12. Lowest common multiple LCM. The lowest common multiple LCM of two or more numbers is the smallest number which is divisible by each one of the given numbers. Understanding LCM. Let us see the multiple of 2 and 3 on the number line. Multiple of 2, 2, 4, 6, 8, 10, 12, 14 and so on. Multiple of 3, 3, 6, 9, 12, 15 and so on. Common multiples of 2 and 3 are 6, 12. Among the common multiples, the smallest multiple is 6. The LCM or lowest common multiple of 2 and 3 is 6. Finding LCM. LCM by prime factorization method. Example 1. Find the LCM of 8, 24 and 36. Solution. Step 1. Find the prime factors of each number. The prime factors of 8 are 2 into 2 into 2. The prime factors of 24 are 2 into 2 into 2 into 3. The prime factors of 36 are 2 into 2 into 3 into 3. 2 into 2 into 2 into 3 into 3. Step 2. Multiplying the common factors 2 and 3 and the remaining prime factors, we get LCM is equal to 2 into 2 into 2 into 3 into 3 is equal to 72. LCM by division method. Example 2. Find the LCM of 21, 63 and 105. Solution. Step 1. Write the number as shown. Divide all numbers by a prime number which divides at least two of the numbers. Step 2. Write the quotient in each case below the number. If a number cannot be divided exactly, write number as it is in the next row. Step 3. Keep dividing by prime numbers until the last row has co-prime numbers with no common factors. Step 4. Multiply all divisors and all numbers left in the row. Product gives the LCM of the given numbers. LCM is equal to 3 into 3 into 7 into 5 is equal to 315. Word problems. Example 1. Find the greatest number that divides 28 and 44 without leaving a remainder. Solution. The greatest number that divides 28 and 44 without a remainder will be the HCF of 28 and 44. Factors of 28 is equal to 2 into 2 into 7. Factors of 44 is equal to 2 into 2 into 11. HCF of 28 and 44 is equal to 2 into 2 is equal to 4. Answer: 4 completely divides 28 and 44 without leaving a remainder. Example 2. Find the greatest number that divides 149 and 101, leaving a remainder 5. Solution: the number must divide 149 and leave 5 as remainder. Therefore, it must divide 149 minus 5, that is 144, without leaving a remainder. The number must also divide 101 and leave 5 as remainder. Therefore, it must divide 101 minus 5, that is 96, without leaving a remainder. 144 divided by 96. 96, 1, 48. 96, 2, 96, 0. Therefore, we have to find the HCF of 144 and 96. We have HCF of 144 and 96 is equal to 48. Answer: 48 divides 149 and 101, leaving a remainder of 5. Example 3. Find the smallest number, which when divided by 10 and 15 leaves no remainder. Solution: the smallest number, which when divided by 10 and 15 leaves no remainder, is their LCM. LCM is equal to 5 into 2 into 3 is equal to 30. Answer: 30. Example 4. Find the smallest number, which when divided by 44 and 55 leaves a remainder of 8. Solution: the smallest number, which when divided by 44 and 55 without leaving a remainder, is the LCM of 44 and 55. 44, 55. 11, 4, 5. LCM is equal to 11 into 4 into 5 is equal to 220. Therefore, the smallest number, which when divided by 44 and 55 leaves a remainder of 8, is 220 plus 8 is equal to 228. Answer: 228. Relationship between LCM and HCF. There is an interesting property connecting the HCF and LCM of two numbers. What do you notice in this table? Numbers considered: their product, HCF, LCM, product of HCF and LCM. 8 and 32, 256. 8, 32, 256. 10 and 15, 150. 5, 30, 150. 12 and 16, 192. 4, 48, 192. 15 and 20, 300. 5, 60, 300. The product of two numbers is equal to the product of their HCF and LCM. First number into second number is equal to HCF of the numbers into LCM of the numbers.